Hello and welcome from the Interactive Information Systems Lab at the School of Information and Library Science at UNC Chapel Hill. I'm Rob Capra, and along with my colleagues Jaime Arguello, Bogum Choi, and Mengtian Gua, I'm pleased to present our work this year on structured annotation of audio data. Intelligence analysis of audio data involves an initial content analysis stage in which the audio data is transcribed and annotated with operator comments, or OCs. It can also involve a knowledge base to store these operator comments and information about entities and relationships between them. It can also involve additional downstream processing by other analysts for quality control and reporting. Our research focuses on understanding the types of operator comments that analysts make and the challenges they face when making OCs. We're also focusing on developing systems to support analysts in making operator comments more effectively and efficiently as they transcribe conversations. In this presentation, we'll talk about two phases of our research. In phase one, we're working to understand the annotation process and are conducting a study with 30 language analysts. In phase two, we're designing prototype tools to help support adding structured operator comments. The study we're conducting in phase one has several goals. First, we're trying to understand what the different types of operator comments are that are made by analysts. We want to know what information is included in the operator comments and how we can structure that information to help provide support for operators making these types of comments. We're also interested in what makes an analyst decide to make an operator comment. In our phase one study, we have 30 participants who are language analysts. We're providing them with transcripts of the Nixon White House tapes in Microsoft Word format and asking them to make hypothetical operator comments at places they would normally make an OC. We want to know what type of information they would include in each OC, in other words, what questions they're trying to answer, and why are they making this OC? In other words, why is it important to answer those questions? Then, at the end of the process, we're asking them about challenges they face in making operator comments. To give you an idea of the types of annotations and structures that are involved in operator comments, let's look at a few examples from a pilot study we ran. In this example, the pilot participant indicated a section of text in the transcript where they would have made an OC about an incomplete context. In this example, we see that the president says, "This is just a battle, it's a war, and we just fight." And the pilot participant noted that they would include an operator comment here to help provide more context. What does the president mean? Who are they fighting? Next is an example where an operator comment would be made to include more information about an entity in the conversation. Here, the comment notes the analyst would have tried to include the name, position, and relationship of Hunt to the overall conversation. Another example is adding an OC to provide background information about an event or person mentioned in the conversation. Here, the analyst indicated that they would include an OC with information about how McGovern is related to this event and why he was being bugged. Another common type of OC is to provide disambiguation about something that is referred to in the conversation. Here, the OC would clarify whether this was the local or national California primary and when it was held. For our last example, OCs are often made to clarify an idiomatic expression or lingo that is used. Here, the OC would clarify what it means to immunize a witness. Next, we'll discuss our preliminary findings related to challenges that participants discussed about entering operator comments. First, they talked about difficulties understanding how the transcripts fit together in a larger context and understanding relations between the actors involved. They also described issues with clearly distinguishing facts versus speculations, capturing levels of uncertainty across the analysts, and a lack of visual cues to convey the level of confidence between operator comments. They also talked about the need for interface tools to reduce the amount of typing required and issues with reading comments that involved ambiguous references and difficulties about knowing the tone of the conversation. We've also begun to create a taxonomy of operator comment types based on our preliminary findings. These include things like disambiguation, acronym expansion, pronoun resolution, clarification, usually about why something was said in the conversation, speculation about the meaning or importance of something in a conversation, summaries, idiom meanings, unstated or missing information that the analyst may know, and background and historical information. Additional categories in our taxonomy include false information, where an analyst knows that false information is being discussed in the conversation, cover term usage, temporal or chronological information, information about a speaker's intent or a speaker's tone, places where novel information is mentioned in the conversation, relationships between entities, and also cases where the analyst looked for information, couldn't find enough, and notes that more information is needed. In phase 2 of our work, we're developing prototype tools to help support analysts in making operator comments as they transcribe audio data. We're focusing on supporting 3 main things. First, structured tools to help analysts enter operator comments and link them to back-end knowledge base entries. Second, detection and labeling of entities relevant to the operator comments. And third, interface tools to help support filtering based on the entity type or the operator comment type. Here's an example where we look at how our prototype could support an analyst trying to make an operator comment to disambiguate an entity in the conversation. In this example, the system has automatically highlighted different types of entities that may be of interest, but the analyst could also manually select text that they want to make an OC about. In step A, the analyst decides they'd like to make a disambiguation operator comment about the mention of gray. They click on the selected word gray. This brings up a display in area B where the system proposes potential entities that might be referred to. Here, the system has ranked L. Patrick Gray and Deep Throat as the 2 most likely entities, but it also shows a number of related entities to help the analyst make a decision. If the analyst then clicks on L. Patrick Gray, they'll be taken to a new form that will allow them to review and enter information for the OC about this entity. After clicking on L. Patrick Gray, a new form is shown that allows them to review and enter information for this OC about this entity. The form displayed in step C pre-fills information from the knowledge base about the entity, here including the name, position, and affiliation. The analyst can then review this information and make changes if needed. They can also add information for this OC about the role this entity has in the conversation and what evidence they have to support their assessment. Finally, a set of radio buttons is provided so that the analyst can indicate their level of confidence in this OC, and then they can click the Submit button to save the OC. Saving the OC connects the OC to this transcript and also connects it with the entity information in the back-end knowledge base. Let's look at another example. In this example, the analyst wants to make an OC with some speculation they have about what's going on in the conversation at a certain point. In step E, the analyst highlights the text they wish to make a comment about. Then, in step F, they can right-click and use a drop-down menu to select the type of OC. In this case, they select speculation. This causes a form to appear on the right at letter G, where they can enter their speculation comment. The system also displays related OCs and related entities that the analyst can use to help fill in the evidence field. Finally, we'll show some of the filtering tools. The prototype can automatically highlight text of different entity types, including person, nationalities or groups, organizations, countries, cities, and states, dates, and times. These can then be filtered, reviewed, and corrected by the analyst using the controls shown on the right. Our current status is that in phase 1, we've begun our data collection and we've begun our preliminary data analysis. In phase 2, we've been developing mock-ups and candidate designs that have been reviewed and presented by our LAS and government partners. We've also begun developing the actual prototype in JavaScript. The main UI components and entity recognition are functional. Thank you for watching our presentation, and feel free to contact us if you have any questions.